All right, so for this first practice problem, we want to approximate the sine of 121 degrees. And the directions tell us that we're going to use the x value of 2 pi over 3. And I want you to first note that 2 pi over 3 is the same as 120 degrees. So we have a value that is very close to our approximation value of 121. So we know that our linear approximation model is L of x equal to f of a plus f prime of a times x minus a. And we want to find these values, and this is where a is going to be this 2 pi over 3. So we have f of x equal to sine of x. So that means that f of a is going to be this f of 2 pi over 3, which is sine of 2 pi over 3. Now sine of pi over 3 is a square root of 3 over 2. 2 pi over 3 is in the second quadrant, and sine is still positive in the second quadrant, so this is the positive square root of 3 over 2. Now we also need to find the derivative of f of x, and the derivative of sine is cosine. And now we'll evaluate this at our 2 pi over 3. So we'll find cosine of 2 pi over 3. Now cosine of pi over 3 is 1/2, but again 2 pi over 3 is in the second quadrant, and in the second quadrant cosine is negative, so this is a negative 1/2. So this gives us our function L of x is going to be this f of a, which is the square root of 3 over 2, plus f prime of a, which is negative 1/2. So I'm going to switch this to a negative 1/2 times x minus a, which is 2 pi over 3. So now we are going to approximate our sine of 121 degrees. Now notice that our linear approximation model is in radians and 121 degrees is obviously in degrees. So to convert to radians, remember that you can multiply by pi over 180. So that would mean that 121 degrees is the same as 121 pi over 180. So to find sine of 121 degrees, we're really finding or approximating the sine of 121 pi over 180, which is going to be about square root of 3 over 2. Hold on, I gotta get my eraser back here. About square root of 3 over 2 minus 1/2 times 121 pi over 180 minus this 2 pi over 3. And when you put this in your calculator, you get about 0.8573.